Morning, everyone. I welcome you for one more class of chemistry. So, dear student, in the last class we have discussed about cells, subshells, orbit, right, and shapes of the S, P as well as the D, right. So, S shell is having a spherical shape and whose capacity to acquire electron is 2, right. So the maximum number of electron when we can add up in the S shell is nothing but how many? 2. So in case of P orbits, these are having dumbbell shape, right, and they can to complete their octet state, I mean to complete the number of orbits present uh, in the P block or else P shell, we require how many electrons? 6 electrons. In the same way, coming to the D, so one we can say here there are 5 suborbits: dxy, dyz, dzx, dx square, y square, and dz square, and it requires a maximum number of how many? 10 electrons. And coming to the F, so we don't know the different cells, but one we can say there may be 7 suborbits, but we don't know their name and all. So but one we can say here it can occupy a maximum number of 14 electrons, right. And remember, each box, that means whatever I say, that is orbit, is they can maximum they can acquire how many? There are 2 electrons. So that means in S there are no suborbits. These are the some basic things you just remember. So no suborbits, only one orbit is there in case of S. Coming to the P, right? So P is having 3 orbits. What are those? Don't forget Px, Py, and Pz, like this. And coming to the D, there are 5 suborbits, right? I'm talking about suborbits. That means like this box. So those are dxy, dyz, dzx, dx square, y square, and dz square. So these are very important. You just remember. So we don't know about the F. So you just remember these 3. That means it has only one orbit. That means there are no suborbits in case of what? S orbit, right? Coming to the P, there are 3. Those are Pxy, Pyz, and Pzx. Sorry, Px, Py, and Pz. So coming to the D, there are 5. And those are dxy, yz, zx, x square, y square, and dz square. So remember these things. So these basics are very important for you to know about the general chemistry, right? So, so in the today's class, we will start the next part of this chapter, that is Planck's quantum theory, right? Which is also very important for 2 marks, right? Planck's quantum theory. Planck's quantum theory. So, quantum is nothing but, you already know, packet of energy, right? So here the scientist called Planck, he explains about the energy, right? So first of all, this theory explains about the energy of what? Electron, absorbed, emission, absorption, right? So whatever the emission, that means whenever we supply some amount of energy or apply external energy to any substance, that means what I said according to the Bohr theory. So definitely the electron will absorb some amount of energy, and then what happens whenever absorption takes place? What happens? It will jump from lower energy level to the higher energy level, right? And then it will come back to its ground state after some period of time. So moving from lower energy level to higher energy level, and from higher energy to lower energy level, what is happening? There may be a formation or emission or loss or gain of energy, and according to him, that energy is nothing but packet, right? He has explained about the quantum, that means packet of energy. So how whatever the emission, gain, loss, or else that means any energy, if it loss or gain, it should be in the form of packet, right? According to him, it should be in the form of packet. We will go point wise, then you can understand very easily. The energy absorbs or emits in the form of packet, right? The first point is the energy absorbed or emitted in the form of packet, right? In the form of packet. According to him, whatever it takes place, that means lower to higher, absorbed or emits. You can say absorbed or emits in the form of packet. That means absorption, the process may be absorption, the process may be emission. There must be packet of energy will be released. That means the concept here is packet of energy means if a compound, say for example electron, so it is an excited state. Remember, I mean, just assume this is the ground state, right? This is the excited state. So that means the electron moves from here to here. That means it will absorb in the form of packet like this. Right? You can imagine packet of energy. That means what he suggests is energy never be what go in loss. That means it makes some work. That's why he said, and that means if the electron moves back from upper, that means excited state, to the lower energy state, whenever it emits, it will be also in the form of packet. That means energy will not be in the form of, right, what we say the light, like it will spread all over. It is not like that. According to him, energy emission also, or absorption also takes place in the form of what? Packet, right? So this is about the first point. This energy is called as photon or quanta. So this packet of energy is called, this energy is called, this means packet. This energy is called, photon or quanta. So that's why we say quantum theory, Planck's quantum theory. This packet of energy is called photon or quanta. Right? So now the last point is the energy absorbed by light is directly proportional to wavelength. The energy absorbed by light is directly proportional to absorbed by light is directly proportional to wavelength, right? Is directly proportional to, and in that regard we will be having one mathematical form of it, directly proportional to wavelength, right? Wavelength. So I will explain you what is wavelength, wave number, right? So these are the some concepts are there in your syllabus. So later we will go with that. So always the energy absorbed by light is directly proportional to what? Wavelength, and this one we can write as energy is directly proportional to the wavelength, right? Or if I remove this proportionality, then E is equal to h by v. That means here h is Planck's constant and it has a constant value, right? So here where E is energy, H is Planck constant, and V is what? Wavelength, right? So this is the mathematical form of Planck's quantum theory. So where I repeat, E is energy, H is Planck constant, and V is wavelength. Don't forget it. So according to him, the energy absorbed or emits in the form of what? Packet. And that packet of energy is called as photon or quanta. And the energy absorbed by the light is directly proportional to what? Wavelength. That means energy absorbed by the light is directly proportional to the wavelength. So I just removed the proportionality constant, proportionality, and then introduced a proportionality constant, that is H. H is the Planck constant, and whose standard value will be always given whenever they ask in the form of what? Problems, right? So this is all about what? Planck's quantum theory. So next is photoelectric effect, right? So the next part of this is, that means the next part of your chapter is photoelectric effect. So what is photoelectric effect? I will just give you a hint, and in the next class we will be having a detailed study about this photoelectric effect. So see, dear student, whenever we, photo means light energy, one we can say. Photo means light. So the sunlight we can see. So photo is nothing but what? Light. So whenever we expose that means chemical compounds to the sunlight, then definitely there might be definitely the change in the internal structure, or else sometime what happens if we keep a very white, that means in the beginning say for example salt only, if we expose it into the cool place, definitely it will dissolve, it will get solid, liquefied. But when we expose that salt, that means the table salt, whatever we use for the domestic purpose, so when we expose it into the more time, so longer time for the sunlight, assume that definitely we are just supplying sunlight 24 hours, then definitely in the beginning it will be very white. And what happens later, it color changes. Why? Because something is going on. That is nothing but the photoelectric effect. The effect which is excited by the light or sunlight, one we can say directly. What happens? Definitely that effect is called as photoelectric effect. See, I will just show you. I will not go directly into the photoelectric effect. Assume that there is some metal or anything. If we are exposing, right? If we are exposing it into the sunlight for a longer time, then definitely what happens? See, all around this matter or a substance or a chemical, there will be an electron, right? So there will be an electron. Definitely what happens when, if the sun wavelength, it will, if it is strong, then what happens, it will directly go and penetrate into that substance. It try to penetrate into the substance, and if it try to penetrate into the substance, then what happens, some of the electron, we cannot say only one electron will be escaping from the substance or two electron. It depends on the strength, that means the strongness of this sunlight. If it is very strong, then might be 10 electron will be removed from the surface. If it is low quantity, then definitely 1 or 2 electron will be removed. If electron will be removed from the surface of a metal, then what happens? This process is called as what? Photoelectric effect. And this photoelectric effect will be produced just because of the light, right? So I have not given assignment for so many days. So dear student, you try to make a assignment on, right? Listen carefully. Orbits, shells, subshells, right? And please send it to me. Why? Because so many days were gone, I have not given any what assignments. And one more thing, you just write the structure of s orbit, p orbit, as well as the d orbit, right? Thank you.